Okay, very good afternoon. So, in continuation with our last class, today also we are going to discuss some of the important other types of a non-conventional or renewable source of energy. So, in that, today's topic is tidal and wave energy. So, tidal and wave energy. So, what is meant by tides? Have you seen tides? Yes, of course, we commonly seen tides in the oceans and sea. So tide means, so it is a periodic rise and fall. It is a periodic rise and fall of the water level in the sea or ocean is called tides. So tides means they are the periodic rise. Rise means it may be for 5 meter, 10 meter. They will have the height, periodic rise and fall. After the rise, again they will fall back to the ocean. Okay, so it may be again there is a one level. In the mean level, there is a up and down. So that is a periodic rise and periodic fall is called tides. These tides are commonly we observe in the oceans or in the sea. Okay, so by using these tides, we can extract the energy. By using these tides, we can extract the energy. That energy is called tidal energy. Okay, so again, wave is a different. Wave means it is a some waves in the deep sea. So these tides are commonly available on the bay of the ocean or beaches, but the waves are available in the deep sea, okay, or main sea part or zone. There are two zone. One is a if ocean is there, the starting means the bay means it is having a some land along with the water. It is called bay. Okay, so on the bay we extract the tidal power. And if you go further into the ocean, that is a main ocean center, there is an waves. Those waves again, from the waves we can extract the energy. That is called waves energy. Okay, tidal energy is different and waves energy is different. So the tides is the sea. These tides are results of course, these tides we can see in the sea or ocean, and they are results of a universal gravitational effect. It is these tides is mainly because of a reason called a universal gravitational effect. Because of the gravitational effect of heavenly bodies called sun and moon, because of the combined effect of moon and sun, it forms the gravitational force. That gravitational force is reason for this formation of tides. The tides are formed due to because of universal gravitational effect of sun and moon. It forms the tides. Means due to the fluidity of water and mass. Of course, water having an mass as well as density. The effect of this force become apparent in the motion of water. Clear? And which shows in periodic rise and fall in the level, which is in rhythm of daily cycle of a rising and setting of sun and moon. Okay, so moon and sun will forms the gravitational, and this the water, whatever the water in the sun and ocean, it is having some mass, and because of this rotation as well as the gravitation, it forms the tides. Okay, there is a flow in the water. Flow in the water causes the tides, and this periodic rise and fall of water level in the sea is called, of course, tide. Okay, and these tides can be produce electric power, which is known as tidal power. And when the water again if there is a one level is there, okay, sea level, if the water which is the tide which is more than that level, that sea level, more than that sea level, it is called flood tide. Flood tide means, flood tide means when the water above the mean sea level. Mean andre just average, we taken a one average level as a mean sea level. If the tides are more than that mean sea level, okay, then we can call it as an flood tide. Flood tide. Okay. And if the level of the tides are below the mean sea level, we can call it as a ebb tide. Ebb tide and flood tide. Because of these tides, we can generate the electric power. Of course, the use of tides of electric power generation is an practically in a few favorable situations. Of course, we need some favorable situations for these kind of power generations. They are not like a solar power generation or wind power generation. Wind and solar power generation, we can wherever we can place the devices and we can extract the solar or wind energy. But these tidal and wave energy we cannot install wherever. Okay, we have to install where there is a bay of ocean or sea. We can install the tidal, and in the mean ocean sea we can place the wave devices where wave means that waves are converted into electric energy by using some devices. Those installations need ocean, particularly some deep ocean for the wave energy, and for the tidal energy they need a bay or just like a beach, near the beach. Okay, we can install this. And of course, uh, the basic principle of this power, here you can see this is a picture. Okay, there are two pictures which represents the how we generate electric energy with the help of these waves and tidals. So here there is a ocean. It's a huge water ocean, having a huge water, and also having a lot of force or power in that. The tides which are having a huge amount of power or force, and we just these waves sorry, these tides. Okay, and with constructing a some installation, this is what the some plant, okay, installed near the bay or beach, and this is a turbine. Okay, green color is a turbine, and here we can extract the, or we can convert one form of energy into another form of energy. So it need a, of course it have a large gates, means these should have a large gate. Okay, and it have a large gate and also have a low head hydraulic reversible turbines, means the turbines which should operate either direction. If the waves are, if the tides are moving in the one direction, it should rotate. If the tides are going back to the ocean, again means reverse direction, again also the turbine should be rotate, means it should be rotate in the both the direction of waves. Okay, the tide basin is formed which gets separated from the sea and dam. It is not in the dam or sea, it should be separate, that basin. Okay, and the difference in the water level is obtained between the basin and the sea. The constructed basin, this is what the basin. Okay, the constructed basin is formed uh, and it is filled during the high tide, and this basin here, there is a basin, means it is a separate water collecting zone is called a basin, where the tides are moving very fastly and it will rotate the turbine and they are collected in the basin. Again once the basin is filled certain level, again that extra water is going back to ocean through the same turbine by rotating the again turbine in the both the direction. Okay, so this is what the basic working principle. By using this working principle, we can convert the tide energy into electric energy by using a both operating direction turbines. The turbines which are operating in the both the directions. Okay, the turbines are coupled with the generator and the potential energy of the water stored in the basin, as well as energy during the high tide, which is used to driven the turbine, and which coupled to generator and generates electricity. Okay, the generator are used to generate the electricity. So this you can observe here. And come to the some of the limitations of this tidal energy. Okay, not wave energy, only for the tidal energy. So working principle ನಿಮಗೆ ಗೊತ್ತಾಯ್ತು how it is working when the tides we see here. This is a pivoting plough device. Okay, so this one, first one, and previous one are the tidal energy. So here this is a basin. Okay, this is a basin, and these are the gates, and here in turn connect with the uh, turbines. When the high tide, when the high tide uh, are enter into the basin through the turbines, and they will rotate and collect it in the basin. And once the basin is filled, again the extra water is going back to the ocean through the same turbine by rotating the turbines. Here the thing, the tides are only rotate the turbines. Once the tides are rotates the turbine having a rotor and stator. Okay, the blades are rotating. Once the blades are rotating, in turn connect with the shaft, and shaft is also rotating, and the shaft connected with the rotor, and rotor start rotating, and it is surrounded by a stator, and it will generate the electricity. By rotating the turbine, it will generate the electricity in the generator, and it is collected either in the power grid, or it will supply to the wherever the electric energy is needed. So in this way we can generate the energy, and this type of energy generation having certain limitations. The economic the first important limitation is the economic recovery of energy from the tides is feasible only at those sites where energy is concentrated in the form of tidal range above the 5 meter or more. If the tide height is more than 5 meter, then only we can able to install. Not if the tide height is not if it is less than 5 meter, we cannot install. Means we cannot install these type of power generations to the river or lake. Only we can install where the high tides are available. And also need a geographic provider. Means exactly it need a bay of ocean or sea. We cannot install near the empty areas or hilly region. Only we can install at the zone of that ocean, that is called a bay of ocean. And due to the mismatch of lunar, of course these tides are mainly because of the sun and the moon. The 30% depends on the sun and 70% depends on the moon. So that where the night, at the time of night, there is a moon is available, so that at the night time the tides are very high when compared to the daytime the tides are, the height of the tide, you just observe in the ocean or sea. When you visit the sea or ocean, the daytime, the tides height, the of course the tide variation, the height is variation is there when they are high at the night time, and they are the tides height are low at the daytime. Okay, because of moon and sun effect, and this is due to the mismatch of lunar driven period. Okay, 12 hours 15 minutes and solar period of 24 hours. The optimum tide generation is not faced with demand. Means we cannot get the optimum tide variation, only we can get high tides or low tides. Okay, that is the another drawback. And changing the tides range is a 2 week a period produces a changing a power. Of course, means the variation in the tides obviously changes with the weekly changes. And if the tides variation is changes, of course it will have impact on the power generation. It will also changes. The power generation also affected by this tides. Okay, and the turbines required to operate in the variable head. The another drawback is the turbines, whatever the turbines we are using to generate here, they should operate in a variable head. Variable head means variable pressures. If the high pressure, they have to operate. If the low pressure, then also you have to operate. Means there is no constant pressure or constant head. They should operate in a variable head. It's a under drawback. And requirement of large volume flows a low head necessity parallel to operate in a many times. Means most of the time it should operating in a low head with constantly producing a power. That is an another drawback. And one more ecological drawback is it will disturb the whatever the marine life. It will disturb the marine life of the whatever the animals or fishes or whatever the species present in the ocean. It will disturb those life. It will affect the ecological. It may harm the ecological balance in the ocean. That is an another drawback. And come to the advantages, it having a so many advantages. It is eco-friendly. There is no pollution. It won't produces any combustible substances, okay, or any toxic materials. It is eco-friendly, and of course it is an inexhaustible renewable source. Okay, renewable source is a, we can generate continuously enormous amount of energy from this type of power generation. Okay, so these are all some advantages, but having in some few drawbacks. And some of the applications where they installed the 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 possible sites of this tidal power plant in India is suggested in the Gulf of Cambay or Gulf of Koch in Gujarat. Okay, and also in the suburban areas in the West Bengal also we can see this type of power generations. These are the some possible where they installed successfully for power generation from tidal to electric energy. Okay, similarly we can go with another type is wave. So energy uh, wave energy, I told the waves, tidal means it is an available in the bay of oceans or sea, only in the beaches. But waves are caused by the transfer of energy from surface wind. Here, the waves are formed just due to because of the surface energy of the wind. The wind energy on the surface of the ocean, it forms the waves. Okay, the surface energy of the wind forms the waves in the sea or ocean. The tides are because of the moon and the sun, but waves are because of the wind. It forms the waves in the sea. The rate of energy transfer depends upon the wind speed and distance over which interact the water. That will decides the energy transfer. The energy flux in the waves is more than the available from the solar, wind, and the other renewable sources. The power in the waves is proportional to the square of its amplitude and the period of its motion. The energy stored in dissipated through the friction at shores and turbulence at the rate depending upon the characteristics of waves and water depth. It is based on this that will forms the waves, and that waves are responsible to generate the whatever the necessity electric power. The wave energy in the ocean occurs likely to inaccessible. Okay, then source potential nearly coastal lines and estimated it is of 20,000, more than 20,000 megawatt. The wave power as usually expressed by kilowatt per minute, and this representing a transfer across the line of 1 meter length parallel to the wave front. Okay, and here you can see this is an another a wave, the second figure, the second picture whatever I shown in the slider, it is the wave energy. Okay, so here there is an plant which having an turbines. Okay, these are the turbines which are completely uh, merged in the ocean, and they are continuously rotating because of the waves forms on the ocean. And waves are generally available in the main sea, not on the coastal region. They are available in the main sea. Okay, on the middle of the sea or middle of the oceans. When the depth of the sea is there, then they forms the waves. And those waves having an enormous amount of energy, and we just extract those energy with the help of these turbines to convert that wave energy to the mechanical or electrical energy. So this is a typical pictures where we can generate wave energy to electric energy. So they are completely immersed. Okay, and they need a strong foundation to support these things, and they have to rotate. The waves are rotates the turbine blades, and in turn the turbines rotate, the shaft rotate, and the shaft rotate, it is connected to the generator, the stator and rotor which run and produces the electricity. And some of the advantages of these waves are it is availability in the large area flux, energy fluxes, and the productivity of the wave condition over a period of day. means the waves are continuously formed, and so that continuously we can extract the energy. It is not like a tide. It is, the waves are little bit a constant when compared to the tides. And difficulties are irregularity of waves pattern. The wave pattern is irregular, means the wave may changes the direction easily. The direction of the wave is not constant, and the phase of the wave is also not constant. It may changes, and it may affect the power efficiency. The power extraction system is exposed to the ocean extreme stormy conditions, means this is completely installed in the middle of the ocean, so that in the middle or in the depth of the ocean, where they have to expose to the some extreme conditions, the extreme floods, the extreme storms may takes place, or extreme thunder takes place, because they have to expose all these extreme conditions. But tidal power plants are generally installed in the bay of the oceans. The peak power of the deep water waves is available in the open sea, where the difficulty to extract and operate, maintain a system and transmit the power on the store, means they have to installed in the middle of the oceans. Okay, they need a strong foundation, and also they need a high maintenance cost, and it is very difficult to construct, operate and transmit power from that point to near to the ocean. It's very difficult. Okay, and the slow and irregular motion of the waves is required to couple to the electric generator, requires to high and constant motion, means sometimes they available a low and sometimes they available a high waves, and with respect to that variation they have to produce the constant electric power generation through the generators. Okay, so these are the some difficulties of waves energy. So waves energy and tidal energy, actually they are different. Of course, they both are produced in the ocean or sea, but one is at the bay of the ocean, and another one is at the open or middle or somewhat deep in the ocean. I will show some videos with respect to the how that energy is converted. Yes, it's first tidal power. It's a type of hydropower. Tidal power means it's just like a hydropower. It is because of the sun and the moon. It causes the gravitational force that cause the tidals. Yes, these are the bay. Coastal lines are bay lines. Okay. So here the high tides and low tide. It's a ebb tide, and another one is a flood tide. And this technology involves. So this is what the, yes, a basin and tides and ocean. There are turbine. It's a one flow, one direction of the flow. It's a dam. Yes. High tide, low tide. Once the high tide is there, it will flow like this, and when the low tide, it will reverse back, and it will rotate the turbine either in the both the directions. So this is what the typical of wave turbines. It is rotating in the ocean because of the waves, and these turbines are rotated and generates the energy. Yes, this is the ocean current. We can also call it as a ocean current. Yes, this is what the water having in more than the air density. So these are the some advantages. Mm. Okay, this is the tidal energy, and I'll show you wave energy. Yes, this is how the another tidal energy is working. So this is what the bay of the ocean or sea, where we can we can capable to install the tidal power plant. So this is a one example. Okay, it's a closed chamber, and here when the water is the, I means the tides are very high tides, flood tides, they are enter into the basin. The turbine. This is what the turbine. Okay, this turbine capable to rotate in the both the directions. This is another application of tidal energy. Yes. The movement of these waves causes the closed chamber, and the movement of this tides rise and fall in that level. It compresses and decompresses the air which is present in the chamber. And if this is what the another application of tidal energy. And here what happens, this entire it is a closed chamber, and once the water level enters, it compresses the air which is present in the turbine, and once it is went back into the ocean, and it decompresses the air. By compressing and decompressing, it will rotate, or it will operate the turbine and generates the electricity. It is an another application of tidal energy. So these are the important applications of tidal and wave energy. Okay, so these are the some advantages, and these are the some disadvantages of uh, tidal and wave energy. So next important type of renewable source of energy is geothermal energy. So geothermal energy, of course, it is also a indirect form of solar energy. But tidal energy is not an indirect form. It is only a 30% depend on the sun, but 70% depend on the lunar, means moon. But here geothermal, it is of course geothermal means whatever the energy which is under the earth crust, that energy directly used to uh, generate the electricity or any useful form of energy, that is called geothermal energy. The geothermal energy is a heat within the earth crust. Okay, this energy which is lies or embedded within the earth, it is called geothermal according to the various theories. I think you already studied in your pucs or school level. There are so many theories. On the earth have molten core. Okay, and the fact of that volcanic, means that is what the evidence, volcanic action taking place in the many places on the earth surface and supports these theories. When the volcanoes takes place, means that volcanoes while coming, means the one hole on the earth crust, that hole leads to the volcanoes which are present in the so many sediments of that earth crust, that having a molten raw material that will coming from deep earth core to the surface of the earth. Okay, that is what volcanoes. And that volcanoes of course having in minerals, materials, there are huge amount of materials, but they are we are having a very high temperature. That is what most observable thing is. They are having a very high temperature, not in the solid form, they are in the molten form. And that steam and hot water comes naturally to the surface of the earth in some of the location on the earth also. I think you heard some of the places, the hot water or the steam coming from the earth. Okay, from the bottom of the earth to surface of the earth. This is also an existence of so many theories. And for a large scale, if you want in a large scale, we have to bore manually, and we can extract those whatever the hot water or whatever the steam is present in the earth crust, and we can convert that heat energy to our useful form of energies. Okay, and this temperature may it is not a atmospheric temperature. It should above the atmospheric temperature. Atmospheric temperature may 35, 36, or 37, hardly 40. But the temperature of whatever the this hot air or steam present in the earth crust, it is having an more than 200 or 300 centigrade, with an pressure of nearly 3000 kilopascal. The pressure is 3000 kilopascal. Our atmospheric pressure is 1, okay, 1 bar, but it is nearly 3000 kilopascal. Okay, it's a high pressure with a high temperature. And of course, this hot air or hot gas or whatever the hot steam present in the earth crust, because of the volcanic action or because of the movement in the layer, whatever the layer present inside the earth, that forms this high temperature substances, and we extract this high temperature substances for our useful things. This is what we call it as a geothermal energy conversion. Okay, and whatever the energy is available from this process is called as a geothermal energy. It is an indirect form of heat energy which is lies under the earth crust. Okay, and there are two important there are two important process or two important method we can generate or we can produce the geothermal energy. First thing is, first type is the heat energy is transformed to a working fluid which operate the power cycle. Okay, which operate the power cycle. Means power cycle means it's a one closed cycle, heating and cooling, heating and cooling. Okay, so if the temperature is high, it will heat and it will change the phase, and if the temperature is low, it will condense and change the phase. This is what the power cycle. Okay, and this may be particularly useful at a place of fresh volcanic activities. So this type of activity we can go with where the fresh volcanic activities are taking place, where the molten interior mass and earth went to the surface through the sediments of that high temperature, and such as between 450 to 500 degrees centigrade can be found, and embedded coil and pipe and sending water through them and can be raised. Means this is a one first type. Here what happens, if there is a fresh volcanic activities taking place. So these are some examples where the volcanic activities are taken place. So nearby this we can drill the hole or make some vent, so that through that we can pass the pipe, we can pass the pipe, and through that pipe we can send some of the substances, which substance are they can easily absorb the energy and change the phase. And in the nearby that volcanic activities, if you drill the hole or vent, and because of that activities there is a high temperature. Okay, that high temperature masses easily change the phase of this substance. Okay, it's a indirect, means indirectly the substances get evaporated by absorbing whatever the heat present under the earth crust, and that heated substance again taken back into the our plant, and where it will done some work, or it will rotate some turbines or do some work, and again back into the condenser where it will reject the heat and change the phase. This is a one power cycle. Okay, indirectly we can absorb the heat. And another type is the hot geothermal water or a steam. The hot geothermal water or a steam which are generated, they are directly taken, and through that the hot air, whatever the hot air and hot water or a steam present in the earth crust, that directly taken, and from that we run some turbines and will generate the power. It is an another way. First type is through some substances, indirectly we absorb the heat present in the earth crust, that what hot steam or hot air, then do some work. But another type is directly that whatever the hot air and hot steam present in the earth crust, that directly take from that surface to the plant and do some work, and it will reject into the condenser, or where the cooling system is there. Okay, so there are two types, one is indirect and other one is direct form. And say this is a application. This is what the working principle of geothermal energy. Here, this is a first type. First type means we installed a pipelines. This is what the pipeline, and these pipelines are under the earth crust, and this is near to the fresh volcanic activities, so that if the fresh volcanic activity is taking place, means there is an enormous amount of heat is present surrounding that area. So we just utilize those heat for our work. Okay, so here what happens, these pipelines are closed ones. First, there is an red color, it indicates that there is a high heat, it will absorb. Okay, it will absorb. See here, this is a pipeline which connects hot water, okay, or a substance which present inside, and this will because of again high temperature as well as high pressure, because of the hot water or a steam present in the earth crust, there is a interact of that substance and the hot water or steam. Because of that, the heat is transferred from higher temperature to the lower temperature, it will gain the heat and it will change the phase, and that change phase with having a high temperature as well as high pressure, that is taken back into the where the work has to be taken place. And here because of that high pressure high temperature, it will did some work, and it will convert the that high temperature high pressure into the some work by rotating the turbines. Okay, and the turbines connect with the generators where it will generate mechanical work to electric energy, and it is again takes place to the power grids where we can store and we can supply for our daily purpose. This is the one way. Okay, and second is I told directly we can extract that hot water or a hot steam through the pipeline, and that hot water and a hot pipe into the turbines, it will do some work, and the same thing, the same turbines, it will do some work, and it will do generates the energy, and same other rest of the things is same. Okay, but is here directly we can extract that hot water or steam, but here we just take the substance near to the hot water and will do some work. That is the difference. And this is what the direct use of the applications in the geothermal. Okay, these are the based on the temperatures we can use different applications. Okay, hot water, and these are the some ammonia we can use as a substances, or some of the refrigerants we can use. Okay, and this is for refrigeration purpose also we can use this type. Refrigeration means the same process is taking place. Refrigeration means the means reducing the temperature of the system below that of surroundings by using this absorption and condensing process. Here also same thing, it evaporator is there, condenser is there, by using that we can do the refrigeration. Okay, and we can go with so many applications. And come to the some of the advantages as well as disadvantages of this type of geothermal applications are, it is of course advantageous, it is an reliable source of energy. Of course we can reliable continuously we can get the energy, and it is available 24 hours, and it is available in independent irrespective of weather condition. If it is a rainy condition or a winter or a summer, we get the constant supply of geothermal energy irrespective of weather condition. It has the inherent storage, because earth itself inherent storage for this energy, and we need not get any storage facility. Okay, and geothermal plants requires a little land area when compared to the power plant, nuclear power plant, hydro power plant. Okay, these power plants need a very less area. So these are the some advantages. But it having some other disadvantages, like generally the energy is available at a low grade heat. The whatever the heat is available, it is a low grade. It is not high grade like combustion of coal. In combustion of coal, we get a high grade, but here we get a low grade. Means efficiency is very less, and continuous extraction of heat from the groundwater may leads to the substances or sampling of land. It may continuous extraction, it may lead to the some of the dangerous activities, like the it may collapse the land, or it may collapse the area, or it may dry out of the underground water. So these are the some problems we may face because of the continuous extraction of this geothermal energy. And geothermal energy fluid is brings with its dissolved gases. It contains some toxic gases, dissolved gases with high pressure, and may leads to the air pollution or pollution of whatever the system. It may causes the air pollution because it is having some toxic materials. And drilling operation needs the noisy process. This we need a drilling process for to extract the geothermal energy, so it may become a noisy process. Noise, there is a huge amount of noise. It is also a drawback. And thermal energy cannot be distributed easily over the long distance, means only with the surroundings of 10 to 20 kilometers of just volcanic activities we get this type of energy. Okay, and corrosion is very high when compared to the other source, and abrasives also there. Along with that, there is some abrasive particles are there, and those abrasives and corrosive particles may harm the turbines blades and turbine systems, so that it can need a continuous maintenance and also very high operating conditions. So these are the some typical disadvantages of this geothermal energy. And applications, this applications we can see in the substantial source of from the energy in USA, Japan, New Zealand, Italy, Mexico, where these countries already installed this type of energy extractions. uh, and in India also we can see this type of energies are Himachal Pradesh are reported, and geothermal energies are exploited huge amount for this daily purpose. And up to this we can extract 7.5 ton of capacity and 250 megawatt of energy we can generate by using this type of energy sources. Okay, so these are the applications. So in the next class, we'll continue another types of renewable energy sources.